Good morning. Welcome to episode number 55 of the Zoomtown experiment. In this episode, we're going to take a look, a top-level look at the rewrite of the Zoomie Control Program. This was not a step I really wanted to do, but as mentioned in the past few videos, there's been a number of problems that needed to be dealt with, some in the form of bugs, others in the form of bad programming, others related to devices that needed to be added into the process for the Zoomie to properly navigate from one location to the other. So before I get into the code, and trust me, I'm going to just do a top-level overview. I'm not going to go through and explain every line of 1,000 lines of code, so rest easy at that point. But I would like for you to understand conceptually what has changed and why. With that, I'll go to an overhead view or an overhead slide thing. Wow, I'm old. Overhead projector back in grade school. My God, those have been gone forever. I'm going to use a PowerPoint presentation and show you some of the information I'd like to discuss. What led up to the rewrite? A big driving factor for this rewrite and a lot of the other technology that's changing had to do with getting the Zoomie to be able to position accurately and report the position it's currently at accurately. And that was the bulk of the driving reasons to everything that's changed recently. One of those things was adding in the tiny code reader to read QR codes, and that would provide very accurate absolute positional data of where the Zoomie currently was. I had some subtle bugs lurking around in the code, and that needed to be dealt with, and most of them were very benign. They were just little annoyances that, oh, I'll get to that later, oh, I'll get to that later, and it really wasn't creating a big problem by itself. But combined with 3 other bugs, it could be a nightmare to deal with. The old code had a lot of leftover and unused test code, as well as a lot of leftover unused local and global variables. This program has been developed step by step for about almost a year right now. And when I program, I often will experiment with one thing or another, and then pick the best solution in my mind at that time. And I try to clean out all the riffraff and get keep the actual good functional code. And over time, I just got sloppy and left a lot of stuff in there, including bits of old code, test code, as well as local and common variables. And most of that is all benign, if it's just that. But again, if other things are going wrong, those things get in the way of finding the problem to develop a solution. It was getting very difficult to find code sections I needed to work on. Boy, that is an interesting statement, and it's coupled to a few other things as well, but I think I've mentioned this many times in the past. I get a very limited amount of time to dive in, do what I got to do, try to film a story, develop the code, etc. I don't have a lot of time to try to dig up or dig through 6 months of history on revisional changes of how I did something. And that gets to be very time consuming. And I just simply don't have that time. So thinking about it, let's make that problem go away with a rewrite. And as similar to the previous example, understanding the original code was getting too difficult and it was wasting time. That just, I think I explained that well with the last topic or the last line item there. It is difficult for me to get back into the code, and that'll be our next bullet point item. The older I get, the harder it is to pick up from where I left off. I'm getting old. I guess this is normal. It's very hard to figure out your train of thought that you had 3 months ago, 6 months ago, 9 months ago, and pick up on that train of thought and refine that idea further. Often by then, I've already moved on to another whole new concept and said, I got a better idea, and ultimately I would have to rewrite code. I'm blaming it on old age. It could have been from having COVID 4 times in the last few years. I don't know, but my memory isn't what it used to be, and my ability to recall things, especially in code, or to monitor code on several different levels, such as the scheduler software and the Zoomie Control Program, it's taxing. It's not as fun and easy as it was just as much as 5 or 10 years ago. So it becomes much more laborious. So overall, the code just became a big old mess. And I needed to rethink a lot of what was going on in the code to try to look at it from a different perspective and to perhaps introduce new ideas that are refined and built upon the experiences of the last year. Rewriting the whole code seemed like a logical direction to go in, so I dipped my toe in it and started tinkering a little bit, and that was, I think, a few weeks ago. It might have been a month or so ago now. I'm kind of losing track. Now the next thing would be what changed in the rewrite. First things first, a lot of the code was reused that was functioning good. And I think that's very true of probably 70 to 80% of the code. A lot of it was working very reliably, or components of an overall function were working very reliably. So all I needed to do was maybe pull out a portion of that logic and substitute it with something utilizing the new sensors or a different way of using a particular sensor, and that led to new capabilities and new features as well. Adding in new functionality, of course the QR code reader's heavily involved in this whole process. Different way of parking and localization relative to parking in the driveways. There's new developments in there. Using the QR code beyond what my original thought was, where I can just leave a Zoomie in a driveway and run a routine that will now say, look for the QR code, when you find it, report back to the scheduler, this is where you are. All around new functionality comes about with a rewrite in a fresh perspective. Written more modular using libraries and classes. If you've been following me along on perhaps on this project or any of the other things that I do, generally speaking, I'm not a fan of classes. Small projects, I think they add work. Bigger projects, they actually minimize work. And I have difficulty sometimes making that transition. What classes and libraries and all that do is allow you to organize things much better. And because I can't keep it all organized in my head over the course of a year with lapses of months in between, being more organized is substantially helpful. And it will also help me keep the code cleaner as we get through this. Furthermore, a good part of the logic will change when you look at code from a modular class-based program. Your way of thinking gets changed, and I'm not sure why, but you look at things from a new perspective. If I just keep plugging away with inline code and a bunch of functions and all that, I don't get that fresh perspective. I might look at things a little different, but it's in the same context of a main program and subprograms. Classes force you to think a little bit differently, and I incorporated that into a number of different functions within the program. To define them right now, don't know if I could, but I know it was very influential in what I was accomplishing during this rewrite. And the last bullet point item, thought processes locked into original code providing a fresh start. If I can't step away from that original code and look at things from another perspective, I am doomed to continue to repeat failures in that code. And that's what going modular with libraries and classes allowed me to do, a whole new fresh perspective. Now with that, we'll go ahead and we'll look at a few of the other aspects of what's going on with the program, just so that you understand bad things didn't happen. One of the first concerns I had with going using classes and libraries is, will it slow down the speed of the program? Universally, I believe people agree that object-oriented programming, classes, modules run slower than inline code with functions. I've never tested it. I've only been told of it. I've never really needed that level of concern about speed up until this project. And this one was an experiment with my deterministic loop, getting the system to run in that method. We saw the bug that I created with that a few episodes ago. At this point, I'm not too concerned about the deterministic loop. I found other ways of dealing with inconsistent time intervals. I prefer it be not that way, but nonetheless, it is what it is. But what I did do, once I got the code to the point that I'm about to show you, is I ran some loop tests to see how long each cycle is without a regulator in it. And I just wanted to show you that information graphed out as I have been doing all along. Now, these are milliseconds here, 1, 2, 3, 4, 5, and 6, or 6,000 microseconds. This is running without QR and without garbage collection. So it's just zooming along here and does something here. This would have probably been a garbage collection that occurred on its own. At some point it detected memory was filled with garbage. That's the big spike here. And then these other ones, this is some task that I'm running intermittently. It's very minimal impact, probably a 200 microseconds, somewhere in that neighborhood. But where we're at on it is about, we'll say 1200 or 1.2 milliseconds is the loop running without a tiny code reader and without garbage collection. Now we'll see what adding in garbage collection does. And here you will see it's a little bit slower in general. We probably went up to about 1.4, 1.5 milliseconds. But our garbage collection is happening at this interval. And it's not fine-tuned yet at all. I'm sure I will tweak with that to depend on when I can keep the peaks lower at whatever frequency I call it. And I kind of figured that was going to behave different when I went to classes versus running functions with a lot of global and local variables. Now this last one is with everybody running and even with some motions in there. When it's actually making a simple motion, it'll go up about 0.2 milliseconds further than what we're seeing here. But other than that, here you're seeing the garbage collection, or I'm sorry, the QR codes all the way across. And occasionally we get one that'll peak up a little bit. But we are now in that 8 to 10 millisecond range as opposed to, for the most part, under 6 milliseconds. So I've lost 2.5 milliseconds looking at the average there. Overall average, we're still under 2 milliseconds when we don't have those special events running. So time-wise, I'm okay with that. It's a non-concern at this point. The next thing would be, how did memory change when I converted the program? And I compared the memory statistics. If you remember earlier on in the project, I was very careful to follow that a lot. So I compared this to a few months back, and I can't really remember when it was that I got this particular, got the sample that I compared against. This is what we've got today. The stack is 548 out of 7936, nothing big there. Our total is still the same, the amount used and the amount free, the number of blocks, block sizes, maximum free size. All of that is very close to what we had before. Very little change. In fact, I would attribute what changes I see here to just differences in the program, not necessarily from inline code to using object-oriented programming, but just simply differences in the code that has been extracted or added to it that would have affected these numbers. So from a foundational point of view, speed and memory do not seem to be impacted at all. So what changed, Chris? That's the million-dollar question. One of the things that I could think of to get the program more readable, more useful for me, was to break it up, as it already was. If you think back in the original code, I had things categorized nice, but they were still all clumped in one big massive program, be it whether they were functions or inline code. So what I did right away is I went through and pulled out certain parts of code, like the motor control. That's pretty well good tested code. I don't have to fiddle around with that. So I created a library for it, built this as a class, and tossed it in there, gave me access to its attributes or variables, and created a few methods for it. And now it runs as an external library being imported. Now I don't have to scroll through this code every time I'm looking for the code that deals with PUB type movements or whichever one I'm dealing with. So once I get rid of Zoom, I call the libraries Zoom Motor Control, Zoom Odometry, Zoom Sensors, and Zoom Status Lights, just as a way to help me understand what's in them. Zoom Odometry, we've got kind of a couple of class variables here, and then the rest would be down here, your attribute, instance attributes or instance variables. But I had to put these up here, as well as import some libraries in this case. This is odometry, so I'm reading the encoders. So I've got to load up the encoder library and then establish the objects for each instance. Then from there we get into the odometry class itself, the big boss. A lot of instance variables in there. And then here are our instance methods all the way through. The code here is, oops, I swore, I got to beep that out. It's darn near identical, with the exception of adding in the self for the dot notation. And you'll see that consists or is consistent all the way through. But again, this information is external library. I just import it. I don't need to look at it when I'm working on the main code. But it's a fairly lengthy one this time around. Now I did develop all this code, converted it to classes within the original main program, using these as the startup code or calls, instantiation for the class, etc. But when I copied it into the library, I preserved that just in case I need to move this back into the main code. I got everything I need to do that, primarily for efficiency. So that motor control handles the movement of the thing. Odometry handles its positional data, almost everything to do with positional tracking and data, etc. The sensors, this one I did need to import struct one of the libraries that's used in one of the classes that I am dealing with. And we'll see that down here. Well, again, in this case, I am doing the hardware configuration and then setting up the tiny code reader in the instance variable code section. And then from in here, I've got the methods to read our Hall effect sensors, to get information from the TCRT 5000 photoreflective sensors. That's the guys that I use for line following, for reading the inch markings, and now for also reading the stop point on the driveway when we pull in to park. The CAS sensor, our collision avoidance sensor, that's constantly checking for stuff in its path, and that is constantly being reported through this method. And then our QR code is handled in here, and here's the function where the struct was needed, and then we're unpacking, and there was another one here too, unpack. Off the top of my head, I'm not seeing it right now, but there was another function within here that struct was used for, calc size. That's what I'm remembering. But nonetheless, all that is outside the main body of the program now. All our sensor data comes from there. Finally, the status lights, which are on the Zoomie itself, that would be, there's an LED, oh boy, I don't know if that'll see it, at the front and the back. Those report status while it's moving around. I haven't fully developed that code yet and how I want it to work. But I've been using it all along during testing. It's been a great feedback device, especially when I disconnect the umbilical cord, aka the USB cable. But that's our very basic function there. This is the one I want to develop further. And then in here we've got a couple other methods for setting the color, blinking, turning it on and off, etc. Not a real big library or class, but nonetheless, it gets this code out of my way. So right now, these are the 4 things that are tucked away in external libraries in classes. In here, I'm still importing what I need, setting our frequency, getting some system parameters established. Not sure if these are actually still going to be needed or not. I do, right now I'm keeping the networking and the communications, MQTT, in the main program because I got a lot of work to do on that to reestablish updated communications between the scheduler and the Zoomie. Eventually I'm going to probably tuck all the network and all of the MQTT off into another library as well. So a lot of this code actually all looks the same as it has been for a while until we get to here are the only few things that are left as far as hardware configuration that are still in the main body, and that is the little black button on the back of the Zoomie here. That has, I use that in certain testing applications. I have yet to find a functional use for it in the real application when it's running experiments. The beeper is this little guy. He's on, I think it was pin 15, and that would beep. Oop, here we go. I don't know if you can see that or not. Why am I not getting a good camera angle? Oh, it's on top of my finger. Let's see if I can get the camera to focus. Okay, right there, that little round thing with the hole in it. That's the beeper. You may have heard that beeping in previous videos. Anytime it saw a magnet, it would beep. And for me, I couldn't tell when it was going over a magnet with our Hall effect sensor. So that beeping noise, I could hear it and immediately look and recognize location relative to the beep and when it saw a magnet. Very handy. Then we're into a position handler. This is sending telemetry data back to the scheduler. This is going to change, so I'm leaving it in here for right now. In fact, it's just commented out, and I'm bypassing it until I start integrating with the scheduler. Here's where I load up all my external libraries and classes. And then this area here, this class is called Process Trip Instructions. I moved away from the wording of trip plan so I could divorce my brain from the old way to the new way. And in some regards, it is very different, what I'm doing now. And I'll cover more kind of in the next video. But we've got our instance variables or attributes. Our methods all start here. And that's line 243. So this is a huge class. I'm just going to go all the way to the end. And it ends at 790. That's a lot of lines of code for one class. But what that one class does is, let's get past all the initialization. The methods start here. Basically, we're going to use this to manage all of the trip plan instructions in old wording. Trip instruction list, till, is what I'm referring to that now as. And then we'll have an executor in there that will execute the list of instructions. And when we process it, the actual list, we will see what action we need to execute, and that would be in somewhat of an English statement, and then we would run that method to perform that function. We've got, every time a function is, or a method is run for an trip plan instruction, it'll run this routine to get all the parameters established for this particular motion type or instruction, whatever you may think of it as. Now in the past, this area down almost looks the same, but I've restructured a few things. We're going to have a beginning instruction. Doesn't do anything at this time. That may actually perform other startup features. And that's really its purpose, is to get things ready to run the whole experiment. Stop function, anytime the Zoomie has to stop, and that would be at any controlled intersection. That would go to this function to run and cause the Zoomie to come to a stop. And the next function that has to run is a wait. W-A-I-T, I just took out the I to keep it in my three-letter restriction. For whatever reason, I came up with that one. But what it's going to do is sit there and wait until it gets the OK to go flag. More often than not, that'll come from the scheduler. The end method, that ends the whole trip per se. Once a Zoomie goes through the whole trip, gets to its destination, it will end that particular trip. And it'll be sitting there waiting idle for the next trip instructions to be sent to it from the scheduler. This next little two codes, the thing you'll notice, I've got a start check address and a perform check address. And that's the way this whole area is structured. When we do a start, that's the first thing that's called from the executor. We got to get everything ready so we can perform it. And that's what these start functions do, or start methods. And that'll run, get everything prepared, turn on certain sensors, etc., and get things going and moving. Then the executor is done with that task. It'll come and run this task now, where it'll perform that. And in here, I will do all the monitoring of the sensor data to perform that action. Certain things, like if I'm going around a sweeping turn, we don't have inch markings, and I don't have magnets for indicating positions, etc. If I'm backing up out of the parking spot so I can look at the QR code, I need to perform that task, and that's what this is about. Perform check address means I'm literally going to back up 2 inches from where it is, wherever that may be, in a driveway hopefully, and then it will be able to see what the QR code is for that location. When that is done, when that task is completed, the next instruction would be to start the check return. We check things, now I need to return, and then it'll perform that task. So it'll check where it's located, it'll back up, look at the code, okay, I'm here, announce that to the scheduler, and then it'll repark itself, so to speak, and that'll be 2 sets of instructions. Pivot turns, those are very specific motions. There's you got either they're forward or reverse, or you're turning left or you're turning right. Based on those 4 conditions, well, 2 conditions with 2 choices each, it will perform that maneuver. And those are fixed position maneuvers. It's blind. It'll just rotate the one wheel far enough so that it turns or rotates 90 degrees. But again, we've got to start, gets all these parameters ready, and then the perform pivot turn. Next up is the sweep turn. Those are on the outer part of the city. They're the smooth gradual turns. They're not a sharp pivot turn. And of course, that has different behaviors. So we have to get parameters set up for that type of motion. And then when we perform it, we're going to go along and check very specifically for certain conditions to occur to judge where it is. And part of that is reading a QR code. Notice how a QR code is incorporated into a lot of this stuff, the different motions, whereas we didn't have that before. Well, with that ability, it changed a lot of the logic to perform that action. And that's what was going on in here. Frankly, it was a lot of fun. Hope it all works in the end. But parking the Zoomie, that will have to be in a certain specific position before it will perform it. Basically, it'll be pivot turned, lined up at the driveway. So we'll do a start function, and then we'll perform that. And then it will drive in to our reference point. And that'll be a change from the old code. I now have that 1/4 inch wide black tape designating a very specific pull-up to point, and then stop at that tape. And that will help me solve a couple of other problems we've been experiencing. And then an unpark is when you back out of the driveway and get lined up to make a pivot turn to go one way or the other. And that is this method in here. A pull-up is when we're coming to the end of a road, like a T intersection, and then I got to pull up across the intersection or into it so I can make the pivot turn left or right. And that's what this function is. That was actually incorporated in a very clumsy way the last time, and I think this is going to work a lot better. It will certainly be a lot easier to deal with when there are problems with it, because now I've got it localized down to almost everything happening within those 2 modular methods. Cruising is when we're driving along any road that's actually guided by our guideline. It'll have the inch markers on it, and it'll have the 0 set magnet and the preset position magnet. So there's a lot of stuff going on during that movement, also including a variety of QR codes that are placed along the roadway. So this one has a lot more sensing going on all the time, and the code base is a little bit longer on it, but it's still not too bad. That's the whole thing, for it to drive along and check all those sensors, etc. And then within that whole class area there, we've just got line follow steering control, and that would be depending upon whatever adjustment we're using for encoder feedback or for our photoreflective sensors. That data is fed into this. This routine then decides go faster or slower with one wheel or the other, and then that allows it to steer. This is the instantiation of that with PTI, process trip instructions. Here's a few missing codes here that I don't use these during development, so I'm just leaving them out for right now. And that would be the watchdog timer setup. And then originally I was going to use a button press to start the Zoomie. I think that's going to be gone by the time I get to the end of this. We're going to preset a few bits of data before we get into the main loop, just to make sure the Zoomie doesn't go running off in the wrong direction or something like that. Clean up some stuff. I'm going to print out the memory info to keep track of that here. There's a speedometer that will check every 20 main loop cycles to check the speed. Not even sure if I need that, but I got the function written and I'm just keeping it handy in case I want to keep using it. Finally, I've got this section of code here called test instructions. And all this is, you'll notice these are the command or trip instruction list items that the scheduler would normally send in here, but while I'm testing at this level, I just copy it or comment and uncomment the various motions that I want to make, such as park and unpark, pivot turn, sweeping turn, etc. So that's all that code there. Now we're into the main loop, and we're going to set the status light to green, blinking every 120 microseconds, I think that is. This all is very, very similar. I got a few main loop counters to decide when I want certain actions to happen so they don't run every single main loop cycle. Clean up the garbage every 50 main loop cycles. Update our status light because those blink, so it's got to be checked on to make sure they blink. Update the position data and calculate the current speed that it's traveling at. In here's probably where I will add the telemetry data for position that would go back to the scheduler. Check sensors. We're going to check our inch markers, our Hall effects, and our casts. And that is currently happening every single loop cycle. We're going to look for a QR code. Current testing is saying I don't have to do it. Actually, that's not 50 milliseconds anymore. It's different from that. But it's 9 loop cycles. And currently that seems to be working. But that's going to all be dependent upon how fast the Zoomie's moving and how far ahead it can see to make sure that it gets at least one image of the QR code before it passes it by. And that would be based on this frequency. Then we process our trip instructions, and I'm not even sure what this guy is. Oh, this is setting the duty cycle. If I need the darn thing to stop and I can get over to it, I can push that black button and it'll stop moving. Had some problems early on and needed to deal with it. And this is the loop speed regulator. I just threw a millisecond in there earlier just to slow it down, and right now I just let it run wide open, and that's it. We'll see what happens there. And I'm doing time checks here, and of course now I'm using ticks_diff instead of doing math. And then if I want to print out any debugging information down here, every 25 loop counts, or whatever I set that to, it'll print out information that I want from within the program. And of course that's while I'm still connected to the umbilical cord. That's a lot to cover. I think I went way long on it. I'm thinking I'm probably in the neighborhood of 45 minutes on this video. I apologize for that. But I did want you to get familiar with it, because now our next video we're going to start dealing with I got most of the code debugged for each of the motions, but we're going to verify that and make any corrections should we find problems on each of the individual motions. After that, then we'll start combining motions into like a normal trip and having it perform a couple of maneuvers successively. and then from there back into integration with the scheduler. So that's what's coming up in the next few videos. I'm probably still on the every other week publication schedule. It's the best I can do with the time I've got. So with that, I'm going to wrap up this video right now before it turns into an hour-long video. Thanks so much for watching, and I look forward to seeing you in the next video.